Everyone, come let's go with starting of starter. Let's begin with need for starters. So it contains starter for DC motor and starter for AC motor. At starting, when the motor is stationary, there is no back EMF in the armature. If the motor is directly switched on the mains, the armature will draw a heavy current because of small armature resistance. This current will damage the motor. From the voltage equation, current drawn by DC motor, already I told you all EB equal to 0. Very beginning, EB equal to 0. So high starting current may result in burning of armature due to excessive heating effect, damaging the commutator and brushes due to heavy sparking, excessive voltage drop in the line to which the motor is connected. In order to avoid excessive current at starting, a variable resistance is inserted in series with the armature circuit. This resistance is gradually reduced as the motor gains speed, and eventually it is cut out completely when the motor has attained full speed. For an example, 5 horsepower 220 volt shunt motor has a full current of 20 amp and an armature resistance of about 0.5 ohm. If this motor is directly switched on to supply, it would take an armature current of 440 amp comes from 220 by 0.5, which is 22 times the full load current. The starting operation of a DC motor consists in the insertion of external resistance into the armature circuit to limit the starting current taken by the motor and the removal of this resistance in steps as the motor accelerates. When the motor attains the normal speed, this resistance is totally cut out of the armature circuit. It is very important and desirable to provide the starter with protective devices to enable the starter arm to return to off position when the supply fails, thus preventing the armature being directly across the mains when this voltage is restored. For this purpose, we use no volt release coil. When the motor becomes overloaded or develops a fault causing the motor to take an excessive current, for this purpose, we use overload release coil. Then we have to see types of DC motor starter. There are 3 types of starters, namely 2-point starter, 3-point starter, 4-point starter. Come, let's go with the 2-point starter. The 2-point starter is used to start the series motor. Start the DC series motor. It contains 2 types. 2-point starter with no load protection. 2-point starter with no volt protection. Initially, we have to know about 2-point starter with no load protection. A 2-point starter is used for starting a DC series motor which has the problem of overspeeding due to the loss of load from its shaft. At this point, we have to keep in mind that a DC series motor never be started without load. A 2-point starter is shown below the classifications. Here, for starting the motor, the control arm is moved clockwise from its off position to the on position against the spring tension. The control arm is held in the on position by an electromagnet. The hold on electromagnet is connected in series with the armature circuit if the motor loses its load. Current decreases and hence the strength of the electromagnet also decreases. The control arm returns to the off position due to spring tension, thus preventing the motor from overspeeding. The starter arm also returns to the off position when the supply voltage decreases appreciably. The L and A or F are the starter terminal which are connected with the supply and motor terminal. L is line, that means supply, F is field, A is armature. If no load protection, when the DC series motor is started without any load, the starting current is very low due to the absence of load. The no load armature current is very low because of starting resistance. Since the magnet is not sufficiently energized to attract the starting handle. So, if the starter handle is placed at run position, it run position back to the off position due to the spring action. The DC series motor is now switched off and no load protection is thus completed. 2-point starter with no volt protection. This is a special starter with 3 terminals such as L1, L2 and A. If L1 terminal that is connected with supply main, then L2 terminal that is connected to a resistance R and no volt magnet, A terminal that is connected to armature and series field. The operation of the starter is similar to the 2-point starter with no load protection. Now imagine the handle is gradually moved from off position. Full starting resistance is connected to armature of the DC series motor and the high starting current is limited. Finally, handle reaches the run position where the entire starting resistance is removed from the series circuit. The handle is kept at run position due to the presence of no volt magnet, which is connected across the DC supply through the resistance R. If there is no resistance, then no volt magnet circuit acts as a short circuit. The starting resistance is connected to terminal A. The terminal A is connected to series field winding and armature of DC series motor. Finally, we have to know about no volt protection. When supply fails, the no volt magnet that is connected in parallel across the supply gets de-energized. As a result, it releases the starter handle. So the starter handle reaches the off position, protecting the DC series motor from no volt. If no volt protection is not there, the starter handle remains at run position. When supply returns, this DC series motor is directly connected across the supply producing high starting current. Thank you.